It's fundamentally impossible to know everything about the universe. It's fundamentally impossible to predict everything.
Welcome to the follow-up question. I'm your host, Michael Ashford. Come with me on a journey as I explore what it means to find common ground at a time when it feels increasingly harder to do so, to listen more than we speak so that we can understand that our differences don't have to divide us. My aim with this show is to bring you perspectives and ways of looking at issues or topics that perhaps you haven't considered before, so that you can then take that new knowledge and apply it to your ability to empathize with the people around you. I'm a former journalist who believes everyone has a story to tell, and it's only when we ask questions and listen that we truly reveal what connects us as humans. Our dreams, our desires, our experiences, our ideas, and who we truly are. As I've mentioned on this show in previous episodes, I'm a big Brené Brown fan. She's written many fantastic books, but her work in Braving the Wilderness continues to inspire me every time I open it. Recently, I went back to Braving the Wilderness to help me describe what I mean when I talk about the third way, that not every issue or argument has just two sides. This false dichotomy that riddles our thinking these days is a huge barrier to our ability to find common ground. But I'm going to let Brené's work do the heavy lifting here, because it's just so good. In philosophy, you're either with us or against us is considered a false dichotomy or a false dilemma. It's a move to force people to take sides. If other alternatives exist, and they almost always do, then that statement is factually wrong. It's turning an emotion-driven approach into weaponized belonging. And it always benefits the person throwing down the gauntlet and brandishing those forced, false choices. The ability to think past either-or situations is the foundation of critical thinking, but still, it requires courage. Getting curious and asking questions happens outside our bunkers of certainty. For most of us, even if the with us or against us mandate sounds a little like oversimplified BS, it still feels easier and safer to pick a side. The argument is set up in a way that there's only one real option. If we stay quiet, we're automatically demonized as the other. The only true option is to refuse to accept the terms of the argument by challenging the framing of the debate. But make no mistake, this is opting for the wilderness. Just fantastic stuff from Brené Brown there. Two things can be true at the same time. You can support the Second Amendment and our right to bear arms in the United States, and you can be deeply concerned with how rampant gun violence is in America compared to the rest of the world and feel that responsible gun laws are needed. You can look and see examples of systemic racism in our institutions and feel that we're not past it yet. And you can believe that critical race theory does more harm than good in teaching racism's role in our history and how we overcome it. You can see the need for restrictions and mandates that help keep everyone safer in the midst of a global pandemic. And you can be concerned about government overreach and just how hard it will be to put that toothpaste back in the tube, to use a cliche. And in the case of this week's guest, you can devote your life to scientific research and discovery, and you can hold deeply to your faith in God. This week, you'll hear my conversation with Heino Falcke, an award-winning astrophysicist who helped lead the team of astronomers that captured the first ever image of a black hole. His new book, Light in the Darkness: Black Holes, the Universe, and Us, is a fascinating recount of how people from all over the world came together to peer into the depths of space in a way that had never been done before. And as you'll hear from Heino, you can look to the universe and see the edges of scientific discovery and physics and the equations that tell us about the cosmos. And you can also see the beauty, the wonder, and the unknowable nature of the stars, planets, and galaxies, and have it strengthen your belief in the existence of a creator. As Heino writes in his book, "For me, natural laws are part of creation, just as I myself am. If an apple falls downward in harmony with the laws of nature, then for me it is excellent physics, but also the expression of a reliable creator who is the same yesterday, today, and for all eternity. For other people, it's just an apple falling." There were so many things in the book that I could not wrap my head around, and I had to read several times to begin to understand. But probably the most prominent one was the image that you and your team actually collected and gathered. We're looking at a shadow, not the actual black hole. Am I correct in saying that?
Yeah, I mean, how do you want to see something that isn't there in a way, right? So because a black hole hides itself behind the event horizon. So the only thing you can see is by what's missing, namely the light that you don't see anymore. So, the only thing you can see of the event horizon is your shadow, so to speak.
You bring this up in the book, the concept of a black hole, how scary it is to us, how just, we can't really wrap our heads around it. If a person were to come in contact or to get close to a black hole, what would actually happen to us?
Well, that depends on how big the black hole is and how well you're shielded, of course, from outer space. If you're approaching a small black hole, then whatever you do, you'll be stretched towards into a spaghetti and torn into pieces. So there is before you even get to the black hole. If it's a supermassive black hole, like the one that we've been taking the image of, which is 1 billion times of 6 billion times the mass of the sun. I mean, 6 billion stars compressed into a little tiny point. And then you have a black hole, the event horizon of the size of a solar system or larger, actually. Then you can, fall into it happily, well, more or less, I don't know, knowing what's going to happen to you. And you can actually cross the event horizon. Not much should happen at that point. Except that, it's going to be pretty hot. I mean, there's some hot gas around. There's a lot of radiation there. And I suppose you can survive that. Then you just fall through this event horizon, and you may not even, you may not notice much until you get very close to the central singularity. It's like a big funnel that you fall into, and it gets and space gets warped more and more, and at some point you get really compressed into a tiny point, and so that will be a little bit uncomfortable, I think, at the very end. Before that, it's a free fall, and you see some spectacular sights, and I don't know, you can explore some physics maybe if you have time.
Do we know how tiny that point is? That
No.
Singularity point?
It's hidden behind that virtual horizon where no information comes out. So there is no known physics that will stop a black hole from collapsing forever in our, in our current universe, in our current knowledge. So it should be becoming smaller and smaller and smaller, and be compressed to an infinitely small point, essentially. Something got to happen there. Now we think some strange physics got to happen there. How can you have so much mass in such small point? Is that possible at all? Some quantum effects need to happen. Some weird states of matter, of energy, strings, what you name it. All kinds of crazy ideas come up. But we have no clue. We really have no clue, how matter and energy behaves under such extreme circumstances, and we can't see it.
The bending of light around the event horizon. Can you actually first describe for the listeners who perhaps haven't read the book, what is the event horizon and how is light bent at that point?
Yeah, no, if you have a star exploding and then the inner parts are, collapsing because under their own weight, and then, at some point the mass is so much compressed that you have so much gravity that the gravity becomes stronger the more matter you have. The more matter you cramp into a small space, the more gravitational attraction will there be, and it will keep becoming smaller and smaller. And the smaller it gets, the stronger gravity gets, and so forth. It's a runaway process, something you cannot run away from, except for collapsing forever into that tiny point. But there is this region around this central singularity, as we call it, the central point, which already is a point of no return, the event horizon. This is not a horizon that you can touch, really. It's not a material horizon. It's just a horizon of what you can see, feel, experience, how it appears to you. Because at that point, that's already the point of no return, where no light can escape the grip of gravity. Think of it of a waterfall, right? So you're swimming in a river and you're going towards the waterfall. It's getting faster and faster as you get to the cliff, so to speak, right? And you try to swim against the flow. And maybe you're a very good swimmer, right? You can, as you are still, before the cliff, you can swim fast enough to actually escape that. But once you're, pulled over the cliff, you're going down the waterfall, really, there's no way you can swim up hills, right? So once you, once you're there, it's gone. And so the same is happening with light. If light or information, anything is outside a black hole, you could still swim against the stream of space, time that tries to drag you towards the central singularity. But, once you're over the cliff, all the light, everything is just gone. It goes down the drain, so to speak.
I was struck by, you made mention in the book that at one point it would be possible, if you were looking forward, to actually see the back of your head. Did I get that right?
The light bending. Yeah, no, the black holes, they curve space. That's what Einstein taught us. In fact, that was the very first confirmation of Einstein theory, was, when they saw that the sun was bending light rays through its gravity, not through its light, but it was, the position of stars behind the sun were actually appearing at a different location because light had to take a little detour around the sun. And this is pure gravity. And, if you make the sun smaller and smaller and smaller, you keep the mass the same. You compress it to like a mile or something like that of radius. Then the light will be bent so extremely. It will not be bent a little bit. It will bend completely. It can actually go around that compressed sun, which then actually is a black hole, to be honest. That means if you're hovering roughly above a black hole, you look straight forward, parallel to that black hole, you look forward, then the light will go around the black hole all the way and come back and hit you, essentially the back of your head. And so what you will see in front of you will be yourself seen from behind. In fact, a few minutes in the past, right? You will see yourself walking. Depending on how big the black hole is, sometimes you could see yourself walking like last week, right there, if you had been around at this point.
See, this is the stuff, Heino, that just blows my mind. Like, I can't even wrap my head around it. I know, I believe in the physics and the science, and what you're telling me is true. It's just so hard for me to grasp.
One physics correction. I mean, your image will be highly distorted. So it's, you probably not recognize yourself, because actually all the light from the entire universe will be bent around. So you see everything mixed up. All the stars, the entire universe, all the light will come towards you in this place. So it will look very strange, like rings and yeah.
Other than the strangeness of looking at yourself from a week ago, right? yeah.
That's probably, you don't want to see me last week. So, yeah.
Heino, the work that you all did to capture the image, the first ever image of a black hole, you turned essentially the entire Earth into a telescope. Mm-hmm. Why was that necessary, to use an array of telescopes all over the world rather than, one or two in a singular point?
I'd rather not have done this. Unfortunately, it was necessary, and the reason was that if you think about what a black hole is, it's a tiny thing on cosmological scales, right? So it's a collapsed star. In the center of galaxies, it's many collapsed star, but compared to everything else out there, it's actually very tiny. And so, fairly far away. So the one that we've been looking at was 55 million light years away. So we're actually looking 55 million years into the past because the light took that long to reach us. And so you take something that is tiny on cosmological scales, is the solar system, right? So you take our solar system, you move it 55 million light years away. It will be so small that you'd need to be able to read the New York Times from Europe with your telescope. You're something that is sort of a millimeter in size, like a mustard seed in New York, or in Europe the other way around. If you're sitting in New York, you want to see a mustard seed in Cologne, where I'm sitting right now, in Germany or some other place. That's the kind of telescope you need. And if you want to do this with radio waves, you need a telescope really the size of the Earth that has that resolution. The bigger telescope, the higher the resolution. And it's just, and of course we could see better if you'd have a bigger Earth, right? So then you would need to build super Earth-sized telescopes to see even sharper, and that's possible by going to space. And the trick, I didn't explain the trick actually. The trick is that you can't build a telescope the size of the Earth, right? And nobody would like that. If you suppose I'm your neighbor and said, I'd like to build a telescope the size of your city, and then you're sitting underneath a big, aluminum dish, whatever, right? So you'd be cranky, I think, at me. And if I do this for the entire world, that wouldn't work either. So rightly so. People wouldn't allow this, and it would be too expensive. But the trick is that you can combine telescopes all over the world. You can store the information. You can receive the radio waves at all different locations, and there are slightly different arrival directions. It will slightly different angle in this telescope than to this. By comparing the waves that arrive, you can actually get an information about the structure of the source. So it can actually. Essentially, what we do in the end, out of this network of radio telescopes, in the computer, we recreate a virtual telescope the size of the Earth, with some deficiencies, but by and large, that's what it is.
And so you're taking measurements with a radio telescope. This is not like a camera going out and snapping images of space. This is, we're receiving information. That information is, am I explaining this right? That information is then calculated, analyzed.
I remember a presentation by a NASA PR guy who told us that like a quarter of half the people were thinking that the Hubble Space Telescope, right, would actually like you would go on vacation, would fly somewhere, take a picture and come back and, give you the picture. That's not how it works, right? Do we have our telescopes on Earth or in orbit, but around? We look at something that's very far out. And that's why it takes so long for the light to come to us. It takes 55 million light years, 55 million years to reach us. Of course, if you would have to go there first, right? You have to travel 55 million years first to go there, take the picture and come back. I tell you, it will take much longer than 100 billion years, because of course we can't travel with the speed of light. So
all of the science was fascinating, but Heino, as we get into what I really wanted to talk to you about today, the last chapter of the book, where you begin to marry your scientific endeavors with your faith, and how that came to be, how you wrap those two around each other. Why was that so important for you to put in the book, to begin to explain that way?
Well, to be honest, it's just the last few pages. And it was actually my publisher who said, was publishing Hawking. And Hawking, was, at the end of his books, he was talking about, is there God or is there no God and whatnot. And they said, they wanted me to respond essentially to what Hawking's been writing. And so in the last, chapters in general, I described where we stand with science, what science can do for you. It has an amazing capability to predict things, to understand nature, but it also has its limitations. And we found that some of these limitations are fundamentally ingrained in our nature, in the nature of this universe. And that tells us that we cannot know everything with precision. It's fundamentally impossible to know everything about the universe. It's fundamentally impossible to predict everything. We don't know how things will be, looking in a few million years and a few billion years, and sometimes, if it comes to weather, we don't even know how it will look in the next couple of days, or at least not in great detail. So why my neighbor gets rain and I don't, right? That's happened to us here. Yesterday it was a major flooding in some, just a few kilometers from here, and then we had no rain at all. It's impossible to predict this with any certainty these days, and that's fundamentally part of physics today. So there is, people sometimes take science as their religion, where they try to answer all questions with science, where they think that everything is completely determined, everything is set in stone. And that's not really the case. Science gives you a lot of freedom to think, to change the world, and to believe, actually. And certainly when it comes to, what at the beginning and end of my life and the universe in general, the fundamental question that we always had, where does it all come from? Where do we go? That has not been answered by science, in contrast to, I think, what people like Falcke and others have been saying. We understood some of the details, but really, overall, this marvelous universe, how this came into being, how it developed, how it made life possible, remains, I think, one of the biggest wonders that we encounter in our life if you think about it, really. There's this sheer fact that we are alive. Every little baby, every little flower remains a miracle, even though if you understand a lot of the physics that leads to it. And so asking these questions about what's the beginning and where do we come from, and is there something more than just the sheer matter that we see, is something that my faith helps me to grapple with, and that people have been dealing with for ages and centuries. And there's a lot of wisdom, and I think in what people have been thinking in the past. And so I think combining this old wisdom with the new knowledge is a very healthy way of going about it.
Over the last year, we've heard trust the science a lot, almost to the point of it being, like you said, kind of a religion. Like the science is unquestioned. When you have heard that in the context of everything that we've gone through over the last year and a half, how do you look at that? And where is the dividing line between, in your mind, trusting the science and understanding there's going to be, as you just said, some things that we cannot know?
I think it's something that needs to be said over and over again. Respect the science, trust the science in the sense of, take the data that's being provided, take it serious. Yeah. Don't just, some people just completely shove aside a lot of body of knowledge, right? That's just so dangerous to do. And I think it has to be said over and over again. On the other hand, science, needs to be put into perspective. Science, gives you the landscape. Decisions you always have to make yourself, and it doesn't tell you, when it comes to questions like love or faith or what your destiny is. Science is not going to give you the answer, and sometimes you have to make decisions which you just can't base on science alone. It has to be based on your personal ethics. It has to be based on what you hope and expect of the future. Of who you are and who you want to be. And it's, science gives you, a roadmap where to travel and what to expect, but it doesn't tell you where you will end up precisely, because things can change. People can change. In a pandemic, for example, right, that we experienced, you can make a model of how, what will happen. And it will happen. We'll have exponential growth, but people will change, right, based off what's going on. And so, your model will change, adapt to what society does. I give another example. You're driving a rally, right, through the desert, and you usually have a pilot in the car and a navigator. And the pilot makes a decision where to go. but the navigator tells you exactly where are we going. You say, okay, in front of me is this cliff. To the left is a swamp. Right is some sand dunes. Right. So that's what science tells you. It gives you the landscape, and then you have to decide. The stupidest would be to say, "Oh, I'll just keep going. Right. I'll just go straight." Well, you're heading for the cliff. That's sure. Well, take the swamp or take the sand. Okay. It's up to you to make the decision. I'll just break, and stand still and say, okay, let's first figure out what's going on here. So that's what science is. It describes the landscape, and but it doesn't give all the answers. That's the important thing. And that's why scientists sometimes disagree in terms of what's the right answer is in a certain circumstances.
How much pushback do you get from taking that view that science is really about the curiosity of discovering what God has put out there for us? How do others respond?
I think it's a mix. Like in Germany, this book actually was a big bestseller, and I was in talk shows, and everybody was asking about science and what I was thinking about, and I would say, to me, indeed, in the end, that's this big mystery, and God is for me, at the beginning and end of this universe. It's just part of my faith. I've been at a Christian faith background, and people loved it, right? So there is still room for faith. Sometimes you read a review on Twitter or on Amazon where they say, "Oh, it's a fantastic book, but why does he have to talk about God?" And I say, Hawking talked about it. I can have a different opinion on it. So why is he allowed to talk about it and I'm not? I think among fellow scientists, I mean, not everybody shares that view, but I didn't have a major problem with it. It's often journalists who ask, and I personally have not had a problem. I just I try to lead a life where I try to be the best scientist I can, and take science as serious as possible. But when it comes to the big questions of my life, I still put my trust in my faith and in God to lead me somewhere, and I know where I'm coming from. I know I'm going there. With all my knowledge, I can't. I'm not going to take my knowledge into the grave. It's. I think what's left of me is what I believe. I think in the end.
You write in the book, science would do well then to accept its limitations and be a partner in a constructive dialogue, instead of elevating itself into the role of ultimate explainer of everything. How does that look like, and how is that carried out in everyday life to be that partner in constructive dialogue? What does that look like, Heino?
Well, I mean, first of all, recognize each other. I think sometimes when you're talking, you see discussions among scientists. Indeed, sometimes some people give the impression all the believers are stupid, or this all thing of the past. Let's just respect each other. But I think I expect from the religious community and from Christians that they do the same. They do respect the scientific facts, and don't make up things, and don't start their own science. That doesn't make any sense. There's one science, and try to be a good scientist. So I mean, and then respectfully listen and take the wisdom that you get from those approaches to the world, and take it serious. And take it on board. I mean, and I think it is important. Let me come back to the pandemic. It's a good example. How do you deal in such a situation? I mean, the science can tell you what happens if you don't do anything. Yeah, and it's very easy to calculate, right? So if you just don't do anything and just everybody keeps on living as they did before, 1 or 2% of people will die. Right, and that's not a lot, right? It's still in a big country. It's in a big country. It's hundreds of thousands, it's millions of people, and so you could take an approach and say, I saw that actually in the Netherlands happening. People were saying, it's just the old people who die, right? So you could make a calculation and say, we let all the old people die. It's cheaper. That would be a very scientific approach, but it would be an approach without compassion, right? it's I don't judge the value of a person just based on his or her value in terms of money or whatever. I mean, every person has a value, and I think that's, to me, it's something that's connected to my faith as well. That every person, even the oldest person, the most disabled person, the person who can't do much, is a loved child of God, so to speak. And it asks me to have compassion. And scientific, you could say, there's no reason to say, these people just cost money for society. Let's just not care about them. It could be. I don't say that my fellow scientists are saying that, but at some point you need a moral judgment, a moral ethical choice that you need to make. How you interpret the data. And sometimes you say, I'll take what maybe costs more. I'll support the healthcare, right? So we'll give money that we care for people. We don't let them die. We don't let them suffer because we care of people, for people. That's an example where science doesn't give you a clear natural answer. Some people say, of course, we wouldn't do this. But, don't forget, we're all still, we have this Christian heritage in us. It gives us certain directions and moral compass. Suppose we wouldn't have that. We'd just ask for science. What is it, what's the right thing to do? I think would sometimes take an awfully wrong decision.
Do we understand the scientific process well enough? Like its goals and outcomes? Do we, as a people, just everyday citizens, understand it and the point of it?
Probably not. Otherwise, we wouldn't have such a problem these days. It's quite interesting that we are in the most scientifically advanced part of our history. We are the most scientifically advanced civilizations. We're using technology, the weirdest technology, sci-fi technology, every day. And using that particular technology, people start questioning the value of science, which brought them all of that to some degree. And so I think obviously people do not understand how science works. And they don't trust it, and that's maybe a big mystery. Why is this so? On the one hand, you need to understand that science is a human enterprise, right? So yes, it's true. At some point, there is a certain opinion coming in. A scientist, when he or she writes a paper, they do a measurement, they describe the measurement, then they present the results, and then they put it into perspective. What does it mean? And that's where personal judgment comes in. And sometimes scientists say stupid things. Yeah, that's pretty stupid. I've seen scientists, certainly when they talk about stuff, either it gets personal or they talk about stuff which is not exactly their subject, or they're missing a point. And only by collectively discussing about it, just exposing the flaws and so forth in the other judgment or and conclusions, you come to a joint conclusion. It's one scientist saying something is never true. I can guarantee it. It's always a collective wisdom of the entire community. That's with trial and error. We err ourselves to the truth. That's how it works. The problem is when it becomes. And it's always also a little bit political, even within science. Which science gets a bit more money and other things. It has the same flaws that normal society has, but I think much less so than actually many other areas, to be honest. And it certainly becomes difficult when science is being used for politics, right? So when you adopt a certain. You actually completely ignore certain facts because you have a certain opinion, a political opinion, because it helps you. And sometimes scientists do that as well, right? So they have a certain agenda and they push a certain scientific theory or whatever, or because of their ego. There are lots of studies in medicine and what you should eat, what you should not eat, which are sort of based on few studies in the past, and someone was pushing it very hard and it got into the news and it got completely blown out of proportion. And people say, I still remember like 20 years ago, you eat eggs, you're going to die immediately, right? So this is, it's not what the scientists said, but that's what, comes to people that listen to this. It's of course not true, right? So so science doesn't work via headlines in newspapers, right? So it works via the scientific community and consensus built up, and and when you hear the science news, it's usually the latest science. And there's a good chance that the latest science is always, it's not wrong, but it's half true only. It's only after a little while that consensus is established.
Yeah, how do we bridge that gap? Because that seems to be, from my vantage point, the missing gap there, that the scientific process is always working to go back and look at, did we get it wrong or did we get it right? It's like it's trying to prove itself wrong. And there's this message that the science is always right. And so when new studies, new information comes out that does prove something wrong, it's pointed at and looked at and said, see, what you said wasn't right because you said this earlier. You must be a hypocrite. I guess that's the question in all of this, Heino, do you feel like sometimes science is labeled hypocritical when all it's doing is following the process that it was designed to follow?
That's certainly something true. If someone says frequently, this was wrong, we have to correct this, I think that's a good sign, right? We consider politicians to say I was wrong as weak, where we should say, that guy is willing to listen and to learn, and that's the person we should be voting for, because he or she said, he understood that they did something wrong and improved. And we have to look at, again, timescales. I mean, it's on the long scales, I think science has been right, but be wary of certain strong conclusions that are being drawn. That immediately jump to a certain. People measure certain brain functions. Electricity pulses in your head. They write a book, and they write, okay, there's no free will. Okay, that's a huge jump. Okay, and so there is a certain scientific measurement that's correct, and a certain interpretation, to a very abstract interpretation, which is there is no free will, or there is no God, or whatever, and that's where you have to be a bit careful, right? When you blur the lines between something that humanity, theology, and philosophy goes about towards hardcore, science of physics and chemistry and other things. At some point, academic discussion, not in all cases there is a clear answer, right? That's
what challenges, you kind of touch on this in the book, but the image that you all were able to collect and capture of the black hole, multi-year project to get the funding, to get this going, to analyze the data, scientists from all over the world in all different countries. What were the troubles and differences that you all faced, yet still were able to come together to achieve the goal that you set out to do? What were the roadblocks and barriers there?
Well, if you have, as you say, science is a long-term project. And it started for me 25 years ago from the first idea. And it was a moment where I realized, we may be able to actually, I think it was more like we will be able to see this. That was this amazing grace moment when you realized it, from some theory and thinking about it for actually a couple of years. And you realized this got to be possible. We can see a black hole, which is, at this time was like crazy. And then you have to convince the others. It always is a long process. So, everybody coming with quick answers, you should also be skeptical about. So, it was a long process of convincing myself, convincing others, discussing about it. And it took almost 10 years that community of the experts said, that should be doable. Let's make this part of our planning. So, 10 years further thinking about it. And then you have to raise the money, do test experiments, and then it's a race sometimes. Who is the first to do it? And those who have better funding or better possibilities are somewhat ahead, right? So I have a head start. And at some point, I felt like I was behind in the race. And others had more money and were able to do it. But it was clear in the end, such a project requires the entire world. It's, because we need telescope all over the world. We needed the world. And so in the end, it dawned upon everybody, you have to do this together. And I think that's a lesson, for this world as well. I mean, we are in competition between countries, between companies, between people. But in the end, we'll need the entire world, right? And so it will not work by just one person or one country dominating everybody else. You have to find ways to collaborate in a reasonable way. And so many of these, the biggest problem is often, what is the right idea? Coming to a consensus. So many of these problems are sociological. Had you given me infinite amount of money 20 years ago, I dictatorial power, maybe, I personally could have done this myself, of course, hiring and enslaving lots of people in a shorter time scale. But I think it's much more important and better to do it together, and B, you never know, who actually has the right idea. Who do you give this money? Who do you give dictatorial power about everything? It's usually, it's usually never one person who knows it all.
Were there other teams working on trying to capture the first image of a black hole?
Well, I think I would claim I was among those who pushed that idea really in the beginning. But experimentally, it was certainly different groups. There were groups in Germany, in the US. It was a very strong group in MIT Haystack and later Harvard that was working on this. There was a group in Germany at the Max Planck Institute, and some others. Our group who was clearly trying to push this, it wasn't always clear that this is going to be a joint project. I mean, initially, like in astronomy, you have typically many groups who do things on their own, and then it's a question who was first to discover something. There are many examples in astronomy where there are two competing groups or three, and then one got the big prize and the others didn't. And that that's in principle a good thing because it motivates you, it keeps things going, and so forth. But again, in this case, it's clear you need everybody. You need to work together because there are telescopes that are all around the world. You needed those telescopes, and some were European, some were American, some were Mexican. So, yeah, it's
what skill, and you were one of the leaders of driving this project forward, like you said, for more than 2 decades. What skill do you think served you best in bringing these groups together to work towards this common goal of finding this image, capturing this image?
I think one thing is a vision. That's certainly important. I think you have to lay out a vision that people, excites people. And this idea of imaging a black hole, at least for physicists, was so crazy that. But also so inspiring that this really would brought people together. I think you have to have the right vision, but then you also need to find the right strategy, and you have to get funding. You have to convince others. And you have to have a lot of patience to do this. You have to tell the story right, and you have to be able to. In the end, you have to build an organization that lasts, right? So some people are very good in going forward, and we rob the bank and we have the money, but what's next, right? So you have to try to build trust, and that takes a long time. And I have a strong ego myself. I want to do things, I want to lead things, but I also learned at least in church actually, that sometimes you have to pull yourself back and have to make sure that everybody has to develop their own talents. That's something how I lead my own group. I want to see my students to flourish, to develop their own ideas. And I tell them, I give them a direction and say, do you want to maybe you want to work on this. I inspire them, but then I let them go, and then sometimes they come and say, I would like to do this, and that doesn't really fit my scientific political agenda, right? It would be more useful if they would do something else. But I tell them, you do what you think is best now for you, and if you're wrong, well, you'll find out. Maybe it doesn't work. Typically, they in a conversation, then you find the right way, right? So, but that's very it takes a lot of time and energy, and you have to be sometimes let loose as well. That people do their thing. But that's the most, the most precious thing, that, if you discover suddenly such a collaboration or your own group, you see many creative people, a lot of creativity, and people work together, and they because they love what they do, and that's the biggest fun. Certainly, if you have a student of your own, which suddenly becomes a leading person and with their own ideas, and they stand there and they get prizes and whatever, I think that's really a great thing to experience.
I know your book was the third in a row of books that I've read that talked about the overview effect, that astronauts that look down on the Earth don't see the borders, they don't see the conflicts, they just see one Earth, one humanity. Is there an inverse of that in looking out into space? Like, what do you call the feeling that you get looking into the deep recesses of space?
I think maybe you can make a name for yourself by inventing that effect, but I suspect it exists. Maybe it exists, and I haven't read the psychological literature yet. But that is certainly one thing that we've all, at least in the past, could have experienced, looking up at the night sky, and we understand this is our universe, this is our world. And so let me say on a smaller level, as a Christian, understanding, there is one God. We're just little people, part of one God. Has a similar effect. It makes you feel connected to others, even if they have a slightly different way of living their religion. And so I think it's certainly astronomers. You see that they share the same sky. And they study the same sky. While they compete on Earth, they understand it doesn't belong to us, really. And so we understand each other to some degree. As astronomers, we're fascinated by the same universe.
I have absolutely been there, looking up at the night sky and just feeling everything that you just described. It's hard to put into words. You write in the book, a scientific image has no value without its story, and our image too would be just a dark spot without the story behind it. What's the story behind your image?
Well, that's the entire book, actually.
Yeah. Can you summarize?
Because it brings together our entire thinking of space and time, our understanding of the universe, the solar system, the story of people coming together and trying to explore that universe, going to the end of space and time, wanting to see this, and finally seeing this dark spot. And if people say something, it's just a donut, right? But knowing that this dark spot is really the event horizon, that's where time slows down, where no information comes back. It's the climax of the theory of general relativity of Albert Einstein. The most extreme object in the universe. All that materializes in this little image, is hidden behind that image. And so you need to understand that story of all humankind and physics and our curiosity in order to appreciate what that image really means. I think it makes it deeper if you understand that story. And without that story, without at least someone telling you what it means, it's meaningless. And I'll come back to the trust in science, right? So if you have to trust us as a collection of scientists, that what we've done is what we say it is. Without that trust, no science means anything. So you always say, it's a facts, it's a data, but it's also the trust that's necessary. And that's true for everything. It's like in politics. If you lost the trust, of your people. And unfortunately, this is happening in some countries. The trust, or sometimes purposely destroyed. It's hard to do anything right. The same with the church. You know, if you lost the trust as a pastor of your parish, as an organization, it's hard to. Even if your message is correct, you know, people will not trust you. It will not have an effect. And science, in that sense, is not different. Of course, you could say, you know, I could do the experiment again. Yeah, but you can't do this experiment, right? Mm-hmm. You as you couldn't make that image.
Yeah,
you would, because you need the experience of the entire radio astronomy community. You need the big dishes. You need to know how to treat this radio waves. It's a huge amount of knowledge that you need to recreate that experiment. So you have to trust those few experts who know, and we have to trust the others. I haven't followed all the radio waves through this telescope. I trust that, you know, what these engineers have been doing, what some of my students have been doing, that this is correct. Of course, you know, I check. You know, I can't trust every little wire in this entire system.
Right. I find myself looking at the image and just staring at it because I know the story. Yeah, you're absolutely right. It would kind of look like almost a solar eclipse if I didn't know what it actually was. It is fascinating to know the story behind it, to have read the book. Where do you go from here? What now, Heino? Now that you've got this image, what's the next step? Next step was writing the book and telling the story. But, you know, for us, this is just the first one. I mean, this is just the first image. And it's something that seemed completely impossible. Certainly, I mean, when Einstein was talking about black holes, he thought they were impossible. Yeah, then 20 years ago, we were thinking, that may be possible, or even 40 years, it just became, and now we see them, but we've seen only one. The next thing is we want to see another black hole, the one in the center of our Milky Way, the closest supermassive black hole to home, still 27,000 light years away, but, you know, much closer. That's our black hole. That's what we want to see. We want to make a movie of black holes, how stuff goes around. We want to see them much sharper. You know, we may want to go into space, build the super Earth-sized telescope, see sharp image. There are still millions of black holes to be seen out there. And then, of course, we hope at some point to see something that isn't well explained by Einstein's theory. You know, there's still hope that we find a new theory that brings together quantum physics and general relativity. There's something deep still to be discovered about space and time that we don't know yet. And so I think this century will be the century of space-time physics. You know, as the last century was a century of particle physics. Now we're talking about space and time and what it all means, and brings us really to the end of our universe. You know, we're looking at the beginning of our universe. We're looking at the end of space and time in black holes, Big Bang and black holes, and these are pretty big questions that we're still grappling with. And the question is whether we will find an answer. I'm sure we'll find something new, but I'm also sure we'll not answer all the questions in the end, which is good. Yeah, as you've made that abundantly clear now and in the book. Before I ask you my last question, I just have to ask, you know, Sagittarius A, it's our black hole. It's in the middle of the Milky Way galaxy. 27,000 light years away. Is that what you said?
Mm-hmm, mm-hmm.
How many years until we're in danger of falling into that?
I once calculated, put it into a slide. I forgot the number. It's many, many years. It takes a little while. I mean, it's not clear. I mean, our sun will die at some point, become a white dwarf. Our Earth will be burned up. Maybe a rock will survive, and at some point, the entire system will be disrupted, or it will migrate then towards a black hole, or will migrate outwards. And I think there's a 90% chance or so that it will probably migrate outwards, but a 10% chance will go into the black hole at some point. But it will be many billions of years away, and the question is what has happened then? You know, in tens of hundreds of billions of years, I suspect, before we end up there.
So we're not in any danger next year or anything.
No, don't worry.
Yeah. Heino, last question for you that I ask of all my guests. What is a question that you wish you were asked more?
I've been asked so many questions. Maybe just quietly sitting there and not asking questions and just, sitting out there, enjoying the night sky, thinking about the universe, life, and God. And in the end, that's what most precious to me, right? I mean, feeling in the end there is a sense and purpose to my life, and that is just being a child of God, so to speak. Enjoying that universe, looking up, asking questions, being loved. And you have me, and everybody here has a right to be on this earth and be respected and loved. Be my message.
I love it. I love it. That's a perfect way to end it, sir. How can people connect with your work, connect with you? Of course, get the book. Just where can people connect?
Yeah, they can follow me on Twitter, Heino Falcke, Heinofalcke.org. That's sort of my webpage. Falcke on Twitter. I'm on Instagram and Facebook. But most quick to respond on Twitter, I think.
Wonderful.
I'm still allowed to be on Twitter. So
I'll be sure to link that up so people have access to that and to your website and the book. So thank you so much for your time and for writing an incredible book. And you've got me asking questions, sir. So thank you so much.
That was the idea. Great. Thank you.
Go out tonight and look at the stars and just imagine and begin to ask questions. You may not have the answers to those questions, but just ask them anyway. Let them rattle around in your head. It's fascinating stuff. So many thanks to Heino for sharing his story, for writing an incredible book, and coming on this show to provide his wisdom and his experience and his insight. Please do me and Heino a huge favor and share this episode with just one person. Share it with one person that you know who might find this conversation super fascinating and interesting, just like I did. Share the episode with someone in your network and help spread the good word about the importance of asking more questions, even if you're just looking up at the stars and asking them of yourself. If you like the conversations with the amazing guests like Heino that I have on this show each and every week, subscribe so that you never miss an episode. Subscribing also helps this show gain more reach. If you ever want to get in touch with me, you can always email me. It's michael@thefollowupquestion.com, or you can go to thefollowupquestion.com and reach out there. I'll catch you on the next episode of The Follow-Up Question, and until then, keep asking questions.